Hello and welcome to AP Psychology. My name is Mrs. Seguin, and today we're going to be talking about the introduction to perception. So this is the second part of Unit 3 of AP Psychology. Alright, let's go ahead and get started. So we're talking about the intro to perception. The last lesson we talked about sensation, which was the stimuli that we were picking up with our five senses, right? Our sight, our hearing, our touch, our taste, and our smell. Today, we're going to be talking about the different ways that our brain organizes that information into something that means something to us, right? Okay, so our learning targets for today, we only have two. We're going to discuss how our experiences and our culture can influence those perceptions and those processes, right? And then we're going to discuss the role of attention in behavior. All right. The first type of perception we're going to be talking about is the perception of movement. So we have what's called a stroboscopic motion or stroboscopic motion. This is our tendency to perceive motion in a series of slightly varied still images flashed in rapid succession. So if you've ever seen a flip book are really cool. If you've ever seen a flip book, basically how that works is they draw a series of stills, like these images are not moving clearly, of still images in rapid succession, and then they flip through them in a way that makes the images look like they're moving. And so your brain is piecing together all of the different pieces, right? And it's filling in the gaps where it looks like there's no movement. And so it looks like this one continuous motion. The next perception of movement, right, the next movement we have is the phi phenomenon. This is when lights flash at a certain speed. They tend to present illusions of motion. Neon signs use this principle to create a motion perception. So if you've ever seen Christmas lights that dance to a radio station, they have those, they're really cool. And you can go sit in your car and turn it to the radio station, whatever song is on, the lights are dancing, right, to that song. They're not moving, but they appear to be because of the way they're flashing. So that's the phi phenomenon. Okay, so the next one is perceptual constancy. This is basically that even though illumination and your retinal images are changing, the image is maintaining its size and shape in your head. So for example, if you look at this image, there's 3 doors. You see 3 same size doors. You perceive 3 same size doors, even though if you actually look at them, they don't look the same size or shape, right? So you perceive in this moment here 3 doors that are the same size and the same shape. That is your brain using perceptual constancy. Then we get size constancy. So stable size perception amid changing size of the stimuli. For example, you think those cars are the same size. Your brain perceives them, assumes they're the same size. What do you assume though? Not that the blue car is smaller than the red car, or that the blue car is further away than the red car. So that's size constancy. The cars are the same size, despite the fact that they don't look the same size, right? And then we get size-distance relationship. For example, the moon illusion. It appears larger and farther away when it's on the horizon, and smaller and closer when it's up in the night sky, right? What makes this happen? Cues to the object's distance at the horizon make the moon behind them seem further away than the moon in the night sky. So for example, you see things in front of the moon when the moon is at the horizon because you're having to see it through trees or, through buildings or whatever it is. But you're seeing it through things. There's things in front of it. And so your brain perceives when something is in front of something else, remember, that the object behind it is further away, versus when it's up in the sky and it's not obscured by anything, you don't perceive it as being further away. Okay, then we get the size-distance relationship. So this is the Ponzo illusion, when we use background objects to detect an object's distance. For example, on this railroad track here, the distant yellow bar appears bigger to us because of the depth cues. See, what you don't see is those 2 yellow bars are exactly the same size if you watch the red bars flash in just a moment. So the red bars, or the yellow bars, are exactly the same size, but because of your depth perception, your depth cues, you perceive the yellow bar that's higher up in that photo or further back in that photo as further away, right? And it looks bigger to you. Now let's talk about sensory deprivation. If you've never done this, this is really cool. I'm actually going to experience it for the first time next month, so I'm excited. This is also known as perceptual isolation. So this can be bad. Let me just clarify this. It's actually a therapy technique for people that get overstimulated a lot or have anxiety or even depression, really. So you go to this, it's called a sensory deprivation tank, and it's a therapy method. And you can go just lay in this tank and just breathe and relax, and there is zero stimulation, and it's wonderful. I'm excited to try it out. But sensory deprivation can be bad. For example, kittens, precious little kittens, right? Who are raised without exposure to horizontal lines. I don't know how you do that, but if you have kittens raised without exposure to horizontal lines, they later have difficulty perceiving horizontal lines. Why? Because their brains don't have a way to process it, right? This does suggest that vision is at least partly something that you learn. Okay, perceptual adaptation. This is your visual ability to adjust to an artificially displaced visual field, like prism glasses. I don't know when you were in driving school if you ever used the drunk goggles where they put on these glasses that are supposed to make you feel tipsy, right? Like you're under the influence, to teach you how it feels when you don't actually perceive correctly. Your depth perception is off, or your alertness level, or your ability to just see what's going on around you, right? However, we can adapt to it. We can even adapt to something being upside down. So then we get perceptual set. This is a mental predisposition to perceive one thing and not another thing. It's a tendency to perceive or notice some aspects of the available sensory data and ignore other aspects of it. For example, what do you see in the center picture? And I'll reveal it in just a second. But first, you see the duck on the left, you see the bunny on the right. Okay, did you see a duck or did you see a rabbit? You probably saw both, depending on, and it's even oriented the same way. You probably saw both, but you could only see one at a time. You can't see the duck and the rabbit at the same time, right? So, how is top-down processing involved here? And we're going to discuss that question in class tomorrow, so make sure that you can actually give me an answer to this one. Schema. Schema is so important to teachers. Schema is basically the framework that you have built in your brain through all of your experiences and all of your learning. You only learn new things if I can attach it to the old things in your brain already. So if I can find an old thing and attach it to it, then you'll remember the new thing, right? That's how you learn. You attach things to your schema. So, your schema is the list of characteristics of an object or a concept that allows us to categorize future unfamiliar information. For schema allows you to know the difference between objects, like what's the difference between a desk and a chair? What's the difference between a bed and a couch? So on and so forth. And those differences and that knowledge develops through experiences, right? So, for example, like when a little kid interacts with a horse for the first time, right? So they learn what the horse is, they learn the sound the horse makes, they learn all about the horse, right? And then one day they see a donkey, and they just assume it's a horse because they have the schema for the horse. They don't know what a donkey is yet. They've never met a donkey, right? So they assume it's a horse, they assume it makes the same noises as the horse, and it does the same things as a horse. Why? Because that's their schema. The schema influences how we perceive that future unfamiliar information, like the donkey, right? Okay, context effects. A given stimulus can evoke radically different perceptions based on the immediate context of the stimulus. Okay, so let's say you get into a screaming match with your mom, right? And then later that day she texts you, I love you, right? Your brain is going to perceive that as, well, I love you, and it's passive aggressive, right? Not because it's actually passive-aggressive, she could really just be saying I love you. But because you had a conflict earlier, it has created context for you to perceive what was texted to you as negative or aggressive, right? So one fun example of context effects is, I actually had friends in college who did this, who would write letters to their parents about these horrible things that they went through, like, for example, robbing a bank and going to jail, right? And they would do this, and it was totally false, in order to create a perception that failing the course isn't so bad, right? And so they get a different reaction from their parents if they start it with, so I robbed a bank, and then they just revealed, oh no, I just failed a course, versus, how are you doing in school? Well, I failed a course. And then there's a big to-do about it, right? And so the context affects the level of perception. Okay, then we get cultural context. This is the context instilled by your culture that also alters your perception. For example, in most Western countries, it is totally taboo to eat animals that are normally pets. Things like dogs, cats, horses, right? It's completely horrible to eat a puppy. That's awful. But in many cultures across the world, that's completely normal. It is completely normal to eat dogs. Your reaction to this thought is evidence of the point being made. The fact that your brain is like, no, your brain can't even compute eating a dog, right? It's horrible. We have a whole villain in Disney about it, right? Not eating dogs, but killing dogs. We have whole villains about killing animals. So in a Western culture, this doesn't make any sense to our brains, right? So that's our cultural context. All right, we have gotten through the introduction to perception. That is all I